Hi, in this video we'll be continuing with the C# tutorials. We'll be going over, so we'll talk a little bit more about fields, and then we'll do an example. We'll talk about constant fields, and then we'll do a GUI example. So the lifetime of a field in the form class, we'll talk about that. So when you declare a field in the form class, the field's lifetime is a time during which the form exists. So the field is, that means that the field's existence in memory will be the time during which the form exists, which means while the form is running. So this means that the field will exist in memory as long as the form exists. This is different than the lifetime of a local variable, which exists only while the method in which it is declared is executing. So a local variable only exists when the method that it is declared in is executed. So for a local variable, when that execution finishes in the method, then the local variable, basically its lifetime ends. So local variables, they come and go in memory often, but a form's field exists as long as a form exists. So therefore, basically the field, which is basically a global variable, exists the whole time the app is running or the form is running. So pretty much the whole time the form is running, or the application or the app is running, is the same thing. So I think we just did this recently in the last example, so you could see. So in the last example in the playlist, if you're following along in my C# playlist, so the name field is created in memory when the form one form is created, and it continues. So you can see that in the debugger as well. You should be able to. That the name field is still existent in memory, so we'll try to do a debugger example soon. Mostly because it's a GUI, which basically you need to click. It doesn't really have an actual kind of execution. Like it just goes line by line. You kind of have to click around for it to get to different parts. I don't really use a debugger with that, but we can try to use that later on. So I can show you how the field exists in memory. So basically, you can see that in the debugger, the name field is created in memory when the form1 form is created, and it continues to exist as long as the form1 exists. When one of the event handlers stores a value in the field, the value remains in the field until it is changed again, perhaps by a different event handler. So fields give you a way of storing values that must not disappear when a particular method ends. So there's some precautions with that. Although fields make it easy to share data among the methods in the class, you should be careful about using them. Overuse of fields can make debugging a class's code difficult, especially if the class has many methods. If an incorrect value is being stored in a field, you will have to track down every statement in the class that accesses the field to determine where the incorrect value is coming from. So in most cases, fields should be used only for data that must be shared among multiple methods. and must continue to exist in memory when methods are not executing. So basically, fields or global variables should be used only for data that must be shared among multiple methods. You might be able to use static for that, but pretty much it still has to be a field. So we'll talk about static, the static modifier later on. So we'll talk about that coming up. So let's just continue on here. So we have constant fields. So a constant field is a field that cannot be changed by any statement in the class. So we'll do an example here in a sec. So a constant field is basically a global variable that cannot be changed by any statement in the class. An error will occur if the compiler finds. Did we talk about this already? I don't think we did. We talked about, let me just go back in my notes here for a sec. Perhaps we talked about constants but not constant fields. Let me just double check that to see what we talked about here. Okay, we did have, let's see. Okay, so we had, so named constants. Okay, so perhaps I might have done it as a field definition, but you could perhaps also make constants local. So if I was doing them global before, you can just note that you can test and see, but you should be able to make, I don't really make constant local fields, but you might be able to. You should be able to, so you can do that. Usually if it's a constant, I make it global, just because you probably need to access it by a lot of different things, but that's not always the case. So you can make a field, a constant, you can make a local variable, a constant local variable, or you can make a field constant as well. So I probably already showed this as a, so sorry, I'm back on the screen here now. But so you can still probably make, I probably already showed this, I mean, it's the same thing. So basically you were just declaring a field here. That's going to be a constant field, which we already basically did. Oops. So private const, so that just means private constant. Decimal, then we'll say, you could just have anything, like this. And then points to some value. So once again, we could probably have a void method here. We'll talk about defining more methods later on. So we could try this. So we could just say that this method just returns it doesn't want me to return unless I have something. So we will do this coming up pretty soon. If you don't know what I just did, I just declared a method that returns a decimal value. And I called it get lot size, so you can use getters or setters, which will help you get things or set things. So in this case I just used get. I just called get lot size. Then here I'm just returning lot size. So here we can could declare another. So we could say that we want. I don't think we can use private here. We could say that we want a private constant decimal lot size, like alternate lot size. Points to like 5.0 or something. Does it? Don't think it wants this to be private. Okay, so the compiler can be strange. It didn't tell me that it didn't want the lot, didn't like the private there. It didn't tell me that. If I click problems, it just says that there's something inspected here on line 22. It says cannot convert initializer type double to target type decimal 23. And I think that's all. It doesn't really say that. I think it just doesn't like the private. Oh, it still says that, okay. Oh, whoops, sorry, so there should also be an M on there. That should be fine. Now if I go private, I still think it doesn't like that. But it's not telling me that, so it's not telling me that you can't use private here, so the compiler is kind of, it doesn't catch everything, so you have to be careful. So you just can't use private there. If you didn't know, that might be tricky because you might spend a lot of time wondering why. Which can be hard, so just know you can't use private for local variables. But in this case we have, we're using the constant, we're making a constant local here, basically. So I think we were supposed to do this earlier on. Well, this is what my notes was getting at, which was this constant local variables, and this is what we're supposed to learn now, but that's okay. Same, doesn't really matter. So this is a constant field, and this is a constant local, pretty much. Variable, constant field variable, constant local variable. So same thing. Oh, sorry, they're not same thing, but they're not the same thing, but they're similar. This is accessible in any method. Lot size is accessible in every method, but you can't change it. You'll get an error if you try to change it. And alternate lot size. Alternate lot size is only accessible by get lot size. And you can't change it as well. So sometimes that you may need that. You may want to have something that's local and a constant. You may want to have something that's global and a constant, so it's up to you. Alright, so let's continue on. That should be pretty much it. So now we have to do, just thinking if we should do it here. Oh, I might actually need to do this in another, I might need to do this in another video because I might need a photo of a coin, which I don't have. That will need to use a picture box. I'm not sure if we used a picture box yet. Perhaps we did. So I'll need to find those pictures as well. So I think we'll have to do that in the next one, so we'll just leave it there. So in this one we just learned about constant fields versus local fields. So just expanding on fields. and then talking about how the memory works with the lifetime of a field and versus the lifetime of a local variable. So thanks for watching. If you guys liked the video, you can like and subscribe to the channel, and I'll see you guys in the next one. Take care.